Hello students, myself Shraddha Agrawal from Holy Hearts Education Academy. Students, today I came with class 11 topic, first chapter, some basic concept of chemistry. And the topic is stoichiometric coefficient as well as limiting reagent. So, the first will be chemical reaction. What do you mean by chemical reaction? A process in which two reactant reacts to form a new substance is known to be product. And the properties of the product is entirely different from the properties of the reactant. Now, if you are going to write it down, a balanced chemical equation, you can predict so many things from that particular equation. So, first of all, if I am going to write down a balanced chemical equation, that is methane. Methane reacts with oxygen to give you carbon dioxide as well as water molecule. I can read out this equation into four forms. The first will be in the form of molecule, that is one molecule of methane reacts with two molecule of oxygen to give you one molecule of carbon dioxide as well as two molecule of water. In term of moles, I will read it out. 1 mole of methane reacts with 2 mole of oxygen to give you 1 mole of carbon dioxide and 2 mole of water. In terms of molar mass, I can read out this equation. 16 gram of methane reacts with 64 gram of oxygen to give you 44 gram of carbon dioxide as well as 36 gram of water. Now, how can you calculate the molar mass? You know that very well. It is the sum of the atomic mass. For example, 12 is the atomic mass of carbon, 1 is the atomic mass of hydrogen. As 4 atom of hydrogen participated, it is multiplied by 4 and hence it comes to be 16. In the term of volume, I can read out the equation. 22.7 liter of methane reacts with 45 liter of oxygen to give you 22.7 liter of carbon dioxide as well as 45.4 liter of water at STP, that is standard temperature pressure condition. So from the balanced chemical equation, I can calculate the number of moles, molecules or the number of gram present in the reactant or the product, or even we can calculate the volume. So what is a stoichiometry? Stoichiometry is a relationship between the amount of reactant and product is called the stoichiometry. So from the balanced chemical equation, the first thing that I am going to calculate is relationship between mole and mole. That means for both reactant and product, one of the substance, one of the species, you are going to get the mole and the another you have to find it out. And you are going to do the calculation by unitary method. For example, how many moles of carbon dioxide will be obtained when 0.274 mole of ethyl alcohol is burned? The first step is to write down the balanced chemical equation, that is alcohol reacts with 3 moles of oxygen to give you 2 moles of carbon dioxide and 3 moles of water. So 1 mole of ethyl alcohol give how many moles of carbon dioxide? That is 2. Then 0.274 mole of ethyl alcohol will give you x mole of carbon dioxide. Then x is equal to 2 multiplied by 0.274 divided by 1 come to be 0.548 mole. Second will be the relationship between mass-mass relationship. That is between reactant and product. We are going to set a relationship between mass of both the reactant and product. Calculate the amount of steam, as water is written in the gaseous state. I will read it out. Steam produced by the combustion of 46 gram of methane. The first step again to write down the balanced chemical equation. 1 mole of methane reacts with 2 mole of oxygen will give you 1 mole of carbon dioxide and 2 mole of water. The equation in the terms of grams, I will write it down. 16 gram of methane reacts with 64 gram of oxygen to give you 44 gram of carbon dioxide and 36 gram of water. So 16 gram of methane gave you how much gram of water? 36 gram. Then 46 gram of methane will give you how much gram of water? Again by unitary method, x come to be 46 multiplied by 36 divided by 16. It comes to 103.5 grams. Now the next will be calculation involving mass-mole relationship. That means one of the reactant and product we are going to take out mass, whereas another we are going to take out the mole. So hence it is known to be mass-mole relationship. Oxygen is prepared by the catalytic decomposition of potassium perchlorate. Decomposition of potassium perchlorate gives KCl and oxygen. If 2.4 mole of oxygen is needed for an experiment, how many gram of KClO3 must be decomposed? That means 2 moles of KClO3 give you on decomposition give you 2 moles of KCl whereas 3 moles of oxygen. So in respect of with respect of grams, I will write it down here 245 gram. How it comes to be? 39 is the atomic mass of potassium, 35.5 is the atomic mass of chloride as chlorine, as well as oxygen come to be 16 multiplied by 3, and the whole is going to be multiplied by 2 because here 2 moles are written. It come to be 245 gram. So 3 mole of oxygen is produced by 245 gram of KClO3. Then to produce 2.4 mole of oxygen, how much gram of potassium perchlorate should be decomposed? So X is equal to 245 multiplied by 2.4 divided by 3. It come to be 196 gram. So in this particular video, we have done about the chemical equation as well as the relationship between the mass, mole as well as mass mole concept. Students, you are going to prepare the notes of this topic and solve NCERT question related to this topic. Thank you.